Hey everyone, and welcome to episode 13 of Q for Problems. Today we'll be looking at problem 13 from the Project Euler problem set, and it wants us to find the first 10 digits of the sum of the following 150 digit numbers. So it basically gives us a list of 100 numbers which all have 50 digits, i.e. they're too big to actually be stored as a long integer. So we'll have a look at the solution to see how we can get around this. We start off by loading in our list of 150 digit numbers, where you can see here that each row is a string containing the 50 digit number. We use capital J as the left operand to the cast operator, and on the right we use a double each both on n, which means that we'll be able to actually go into each row, i.e. each string, and go in and cast the individual digits. So you can see here that each row now is a list of longs, which are the individual digits. We next apply the sum keyword, which will do a sum on each column of this large matrix of numbers. And so the first item here is the sum of the first column. And we've saved the result into S. So this essentially groups all the different powers of 10 together. So the first column is actually that number times 10 to the power 49. The next column will be that number times 10 to the power 48, and so on. To demonstrate this next part, we'll set x and y equal to the first two terms in S respectively, and in order to add two adjacent terms in S, we need to scale the left term by 10 because it's actually a power of 10 higher than the right term. We turn this scaling and adding into a function and use the scan operator so we can apply this iteratively across the list of S and thus add in each successive term. The result of this, which we shall assign to D, is essentially a running sum where we're adding the most significant terms first, and essentially the number is getting larger and larger as we go. All that remains is to check for the first number in D which satisfies two conditions. The first condition is that we have at least 10 digits, so here I'm actually going to check that it has more than 13 because adding the 11, 12 and 13 terms is most likely going to affect some of the last few digits. And the second check will check the 11th digit of the number to make sure it's not a 9. So the reason for this is that having a 9 here can cause a cascading effect if we add to this 9 and it becomes a number greater than 9. And here we have a 10 vs each both D. So essentially this breaks a number down into its digits. So you can see here that 506 is broken into a list 5, 0 and 6. And then we essentially select the 10th index, which is the 11th item. So we leave the first one blank because that will do it for all the rows, and you can see that will give us a Boolean result. And we just want to add these two checks together, and then we just want to select the first value of D which satisfies both those conditions. Then we convert the number to a string and take the first 10 items, i.e. the first 10 digits, which gives us our result. And then we finish off by combining this into a function and we apply it to n, and this gives us the expected result. Solution 1 works for this problem. However, in the general sense, it could fail if our number, which is about to exceed the limit of a long integer, ends with a load of 9s and we can't actually be certain that adding the next term is not going to affect the first 10 terms. The problem really boils down to the problem of being able to store and work with a large integer value that's larger than the limit of a long integer. We tried to overcome this in solution 1 by converting to the individual digits and then working with those in a column-wise order based on the significance of the digit. However, we can actually just keep the value as a string, i.e. the large number as a string, and create a function which can add strings together. We'll demonstrate this solution by creating an example variable, which we'll call x, and using a smaller list of strings just so it's easier to visualize. To add strings, we will still at some point need to convert the individual characters into digits, in which case we'll use a very similar method as last time. However, rather than having the two each boths, we will use an each right, and this will become clear in a minute. In order to make our add strings function generic, it should be able to add strings of different length, i.e. numbers that have different numbers of digits. So to do this, we use an overload of the $operator, So on the left we have the max count of each x, which is the maximum length of a string of one of the strings, so whichever string is the longest, and we negate this because this will add left padding. And on the right we have each right on x, which will do it on each of the strings. However, we must note that if we take our example and add an extra term to it, that is a single character, then line 8 will actually return a type error. So what we need to do is make sure that every term is enlisted, and we can do this by joining on the empty list. So putting this all together now, remember that I mentioned that we were using each right, and the reason is because all three of the bits of functionality we just looked at use each right, which means we can actually just use it once here in this final part. So you can see that now we just have an apply each right on x, and on the left we have the three parts that we discussed. And we can now fill the empty or null positions with 0, and you can see that everything lines up now based on its actual decimal position. So we clear the screen and then we just sum each column similar to how we did before, and we will assign the result to S. And so now you might notice that S is actually not individual digits, it contains ones that are above the value of 9, and which case these are positions that need to include a carry. So for example, the 2 from 26 needs to be carried over to the 14, and the 1 from the 14 needs to be carried over to the 5. We can get the carry term by simply dividing S by 10, and we will assign that to the variable d. And to get the remainder after the carry term is removed, we can simply do the modulus. And you'll notice here we're doing this manually rather than using the mod keyword, because we want to avoid using the div twice. So this part is just equivalent to S mod 10. And then we join a 0 to the front of this to account for overflow of a carry term from the leftmost term. And in order to make the carry terms the same length, we can join a 0 to the end, because there will never be a carry term coming from the very right because there was no term before it. And we can simply just add these together. And we simply assign to S, and then we can just check if the first term is a 0. If it is, we remove it. This was the term that we used to make sure there was no overflow from the very left term. We then just use over to apply this iteratively to S until it converges, as there is a case where adding the carry term can lead to another carry term needing added. And we can convert this to a list of strings and then flatten it to a single string. We can then put all this into our function, add strings, define it, and then we will define S2 as 10 take the add string applied to some argument, and then we will apply S2 to n. And this gives us the expected result. Looking at performance now, we have everything defined as before, and we apply S1 and S2 to our input n and run it 10,000 times. And we can see that S1 takes around twice as long as S2 to run, where the memories are very, very similar. So overall, S2 is more efficient and also a more general solution. That's everything. Thanks for watching. I'll see you in the next one.